Hello everyone, I am Mrs.N.Umamareeswari, Assistant Professor of Chemistry, SFR College for Women, Sivagasi. Today's topic, the phase rule in thermodynamics in physical chemistry. First, we see about the phase rule. First, we see about the learning objectives. To know the basics of phase rule, to study the types of component system in phase rule, to understand the concepts of phase rule, to apply the phase rule in water system. First, what is meant by phase? Any homogeneous part of a system having all physical and chemical properties the same throughout. Ordinarily, three states of matter, that is gas, liquid and solid, are known as phases. Next, we see about phase rule. A rule relating the possible number of phases, constituents and degrees of freedom in a chemical system. This gives phase rule formula, that is F is equal to C minus P plus 2, where F is represents as a degrees of freedom, C is a number of components and P is a number of phases. A system may consist of one phase or more than one phases. A system containing only liquid water is one phase system. So P is equal to 1. A system containing liquid water and water vapor is a two phase system. So P is equal to 2. A system containing liquid water and water vapor and a solid ice is a three phase system. Therefore P is equal to 3. A system consists of one phase only is called homogeneous system. A system consists of two or more phases is called heterogeneous system. Next, we see about the applications of phase rule to water system. The system water is a three phase and one component system. The three phases involved are liquid water, ice and water vapor. All these phases can be represented by one chemical entity, that is H2O, and hence it's a one component system. This is the water system diagram. This O represents the triple point, OA curve represents vaporization curve, OB curve represents sublimation curve and OC curve represents the freezing or melting curve. And the final OA dash curve represents supercooling or metastable curve. First, the features of the phase diagram are listed below. The curves OA, OB, OC. As I already told, curve OA represents the vapor pressure curve of water. Curve OB represents the sublimation curve of ice. Curve OC represents the fusion curve of ice. Along the OA, OB, OC, there are two phases in equilibrium and one component. Therefore, F is equal to 1 minus 2 plus 2 is equal to 1. It has 1 degrees of freedom, that is monovariant. The triple point. The curve OA, OB, OC meet at the point of O, where all the three phases liquid water, ice, vapors are in equilibrium. So these are three phases and one component. So F is equal to C minus P plus 2 is equal to 1 minus 3 plus 2 is equal to 0. So the system at the triple point is non-variant. The areas AOC, AOB, BOC. Area AOC represents conditions for the one phase system, that is water. Area AOB represents conditions for the one phase system, water vapor. Area BOC represents the conditions for the one phase system, ice. All the three areas there being one component and one phase. So applying to the Gibbs phase rule, we get the system is bivariant. And the final one, metastable system, supercooled water and vapor system. The dashed line, that is OA dash in the diagram, water can be supercooled by carefully eliminating solid particles. The supercooled water system is metastable or unstable. Thank you for watching this video. Thank you.